Hi class, today we're looking at chapter 3-1, relating graphs to events. You may have previously seen graphs in newspapers, books, magazines, sometimes our textbooks, to display data. A graph shows complex relationships between variables in a simple visual way. Drawing a graph makes it easy to analyze data. You can use a line graph to see if it is increasing or decreasing, and if change in data is linear or non-linear. So a change in data is linear if it forms a straight line when graphed. If data does not form a straight line when graphed, then its change is non-linear. Let's go ahead and write that down. Okay. So I put linear is when a straight line is formed, non-linear is when it is not a straight line. So looking at this graph right here, we see that this beginning part here, I don't want that. The line's not straight, but yet if you look right here, it is straight. So this is non-linear on this side and linear on that side. So let's go ahead and look at this graph. It's showing the altitude of a helicopter, so how high it's going, and the time it takes to get there. So when is the altitude increasing? So if we look from here to here, it's all on an increase. It's going up. So this point right here is 10. So when is the altitude increasing? From 0 to 10 minutes. When does the altitude decrease? It goes down from 10 to 20 minutes. So from 10 to 20 minutes. When is the change in altitude linear? So I gave that away earlier when I talked about how this was a straight line right here. So it is linear when the altitude is decreasing. So from 10 to 20 minutes. But it's also straight right here. It's linear right here also. So from 5 to 10 minutes. See, I just followed that down. So from 10 to 20 minutes and 5 to 10 minutes. When is the change in altitude non-linear? So it's non-linear right here from 0 to 5 minutes. Between which two times did the speed of the helicopter increase the most? So if you look on the chart, and just to see, let's try to get rid of some of this here. If we look between 0 to 5, it went up 3,000. So that first one was 3,000. And then from 5 to 10, that increased from 3,000 to 5,000. So that was only a 2,000 increase. So it says at which two times did the speed of the helicopter increase the most? From 0 to 5 minutes. Okay. So now let's look at sketching a graph. Kim measured her pulse rate occasionally during a 45-minute workout. The workout included a 10-minute warm-up period and a 10-minute cool down period. Sketch and label a graph showing her pulse rate during her workout. So the graph below shows that as Kim warmed up her pulse rate, so here's where she's warming up the first 10 minutes. Her pulse rate increased. While she was in the middle of her workout, her pulse rate was high but stable. So right here, high but stable. The cool down brought her pulse rate down again. So then this is the last 10 minutes. Cool down, warm up. Okay, so this is just sketching a graph. On this side was the pulse rate, and down here is the time. So let's look at our next example. Use the following information for exercise 1 through 5. A student wants to sketch a graph that shows the distance of a bus from the transit center during the morning commute. The trip includes 3 stops where people get on and a highway where the bus travels at 50 miles per hour. So why should the student use a line graph? What are your thoughts? Well, really, a line graph displays the best change over time. So let's go ahead and put that down. What label should the student put on the horizontal scale? What label should be on the vertical? So it looks like to me that they are wanting to go talk about the distance. Wants to graph that shows the distance of a bus from the center during the morning commute. So then the other thing it looks like they're talking about to me is time. So I would say we should do horizontal. Let's do time. And it could go either direction. And vertical, let's do distance. When is the line on the graph parallel to the horizontal axis? So let's kind of draw this out so we can get an idea. So we're saying that we're creating a graph that looks like this. This is going to be the time down here. So 0, 5, 10. We don't have the data to actually fill this out, but just so that you kind of get it. And this is going to be the distance the bus is from the center. Helps if I spell that right. Okay, so this might be 5 miles, 10 miles, 15, 20. Okay, so when is the line on the graph parallel to the horizontal axis? So parallel means that it's the same right there. The only time that that would be the same, because otherwise, right, he's going farther away or he's coming back. The only time that it would be steady is when he stopped. Because if he stopped, then he's not going any farther distance-wise, but he still is spending time. So when the line on the graph is when the bus stops. When is the line farthest away from the horizontal axis? So it's the farthest away, so like way over here, is when the bus is farthest from the transit center. When the bus is farthest from the transit center. Okay, which section of the graph should be steeper? The section for the bus on the highway or the section on the bus in the city? So it said that it was going 50 miles per hour on the highway. So to me that means that it's going farther away faster. So the highway would be the correct answer. Because it's traveling at a higher rate of speed. Okay. Your homework for tonight is page 84, number 7 through 15. Odd.